the basic details for Fcfs scheduling algorithm. Okay. Then we will start implementation on that. Then in the next session we will start with the rest of the scheduling algorithms. Okay. Actually, this now we have to study scheduling algorithm. So scheduling algorithm is basically related to processes, scheduling of processes. Whenever there are multiple processes in the system, that time we need process scheduling algorithms. Means whenever there are multiple processes to be executed, waiting for execution. Then which process to select for execution. So this selection is done based on a scheduling algorithm. So first we will see what is scheduling algorithm, what is process. Okay. Then we will start. Then we will see actual implementation of FCFS scheduling algorithm. So first we will see what is process. Meantime, you may be talking where while doing the program, you will say multiple programs I want to execute, multiple processes I want to execute. So process is what? Process is nothing but it is one program in execution. The execution of process must progress in sequential fashion, and actually process is not as same as program code, but a lot more than it. Actually, process is an active entity as opposed to the program, which is considered to be a passive entity. Means if we consider process and program, so process is active entity and program is the passive entity. The attributes held by the process include hardware, state, memory, CPU, etc. Process is defined as an entity which represents the basic unit of work to be implemented in the system. So it is just like a program only, but not similar to program. Okay, process is a program in execution which then forms the basis of all computation. Okay, generally we write our computer program in a text file, and when we execute the program, it becomes a process. Okay, which performs all the tasks mentioned in the program. So when a program is loaded into the memory and it becomes a process, it can be divided into four sections. Okay. Whenever sometimes you're writing program in text file, whatever, it, whenever you execute that program, it becomes a process that performs required or mentioned tasks in that program. So whenever it is time to load that process into the memory, it becomes a process. Okay. And for each each process is divided into four sections: tag, heap, data, and text. So maybe you're familiar with this tag. Actually, stack is used for storing local variable. Space on the stack is reserved for local variables when they are declared. And next, the heap section. So heap is used for dynamic memory allocation. Uh, means if you remember, we have maybe you use dynamic allocation operator, that is new, delete, malloc, free. So it is used for the dynamic memory allocation. This heap portion. This is the some portion of memory of a process. Stack, heap, data, and text. So stack is used for storing local variable. Heap is used for dynamic memory allocation, like it is managed by new, delete, etc. Then data section is there. So data section is made up of the global and static variables which are allocated and initialized prior to the executing the main program. Okay, and text section. So text section is made up of compiled program code, or it is made up of compiled program code. So this is nothing but is a part of a process. And again, whenever we are seeing multiple, maybe multiple processes into the system, so what happened? Uh, Some of actually processes are having various states. Maybe one type process is a new state, ready state, running, terminated, waiting. These are the five main states of a process: new, ready, running, terminated, and waiting. Okay. So from the name itself, what you can say new. So when the process is newly created, that time we can say that process is new state. Because why we are studying this actually when you will solve problems in scheduling algorithm, that time maybe you will require this term. That's why uh, we are studying this basic term. So when the process is created, it is in a new state. Now once the process is admitted, now next state is the ready state. So what it indicates, the process is waiting to be assigned to a processor. Okay. When the process is newly created, it is in a new state. Now, after new state, um, next time the process is waiting to be assigned to a processor. Means the process is waiting for the service from the processor. So those processes are known. Those processes are in a ready state. Okay. Now once the process is on ready state, now next it is running state. So what is mean by running state? Running state means now instructions are being executed. Okay. Once the processes are in a ready state, ready state means processes are waiting for the processor to be allocated. Now here you can see scheduler dispatch is there. Scheduler dispatch is a one software program that will select the processes from the ready. Actually, queue is there, ready queue is there. This will not happen. Only one process is there that will waiting for processes to be there. It may happen that there are multiple processes enter into the system. Then one by one they are in a ready state, running state. Okay. So what will happen? As the processes are entered into the system, they are kept in a ready queue. Means in ready queue, multiple processes are there that are waiting to be assigned to a processor. Okay. Now, scheduler dispatch will select one of the processes from that ready queue and selects for execution. Now, once it selects that process for execution, that process is in a running state. Means instructions are being executed of that process. Okay. Whenever instructions are being executed, we can say that the process is in a running state. Now, it may happen that during the execution of process, interrupt may occur. So, once interrupt occur, again that process goes in a ready state. Means during that time it will handle that interrupt service routine, whatever. Once that interrupt service routine is complete, that process again comes into a ready state. Okay. And during the running state, if one of the process requires any external service or input output service, then again that process goes in a waiting state. If particular process has to wait for some external service or for some input operation, then instead of keeping in a running state, that process is kept in a waiting state. So that there, so here also one queue is maintained. Once the waiting of that process is finished, that process again goes to ready state. So from ready state, scheduler dispatcher will select the processes according to their criteria. Now, once the process finish their execution, then it will go to terminated state. So the process has finished the execution. Terminate means the process has finished the execution. So these are the five main states of the process: new, ready, running, waiting, and terminated. New means process is process is being created. Ready means process is waiting assigned to processor. Running state means instructions are being executed. And waiting means the process is waiting for some event to occur. And terminated means the process has finished the execution. So it may happen that a process is in one of the five states. Now we are saying process. This is the process state diagram. Okay. Once the process enters into the system during its lifetime, the process may be in one of these states. And to maintain this information, actually, process control block is also there for each process. Whenever we are saying there are 10 processes in the system, so for each process there is a process control block (PCB). PCB is there for each and every process. Okay, means each student have its own roll number. So like that, each process is having its PCB, that is process control block. So this is just to maintain the information about that process. So these are the some fields of that process ID, state, pointer, priority. So process state means now we have process ID. So actually it may happen that process ID is there along with each process, and if process is created by the parent process, so their IDs are different. So here process ID is there, it will be different for each process. Then state, now only we have storage key, which are the states of a process: new, ready, running, waiting, and terminated. So it can be running, waiting, or etc. Then here you can see various program counter CPU registers are there. So CPU register and program counter, this information is maintained in the PCB. So what is the program counter here? Actually, this program counter holds the address of the next instruction to be executed for that process. Okay, it will happen that for one particular process many instructions are there. So we know the normal working of program counter holds the address of next instruction to be executed. So here in this case, program counter holds the address of the next instruction to be executed for that process. And CPU scheduling is also CPU scheduling information is also maintained here. CPU scheduling information like priority. Oh, whenever processes are there in the system, sometimes priority is also assigned to some processes. Means priority is just like a level. One indicates high level, two indicates little lower level. So sometimes priorities are mentioned along with process. So priority information and pointers to scheduling queues. This information is also maintained in the PCB. Also here some of the fields are like counting information. So the user and kernel CPU time, consume, account number, limits, etc. are held in this field, accounting information, because user mode is there, kernel mode is there. So user and kernel CPU time consume is also maintained in the PCB. So IO information is also there, like device allocated, which are the open file tables like that. So all such information is maintained in the PCB. So there is a process control block for each process, enclosing all the information about the process, or it is also known as task control block. So it is nothing but it is just like a data structure. Okay, it is like a data structure for the process. Now we will see what is mean by scheduling. Okay. So CPU scheduling refers to the set of policies and mechanisms built into the operating system that specify the order in which the work to be done by a computer system. Okay, this in short, this scheduling will determine which process to be selected for the execution, or specify the order in which the work is to be done. So schedule is an operating system module that selects the next job to be admitted into the system. Okay, so it selects the next job which is to be admitted into the system and next process to run. So what is the main objective of the scheduling algorithm is to optimize the system. Means CPU should not be idle during its lifetime. Okay, this is the main task of this main aim of this scheduling algorithm. Optimize the performance of the system. Means CPU should be busy at all times. This is the main objective. So CPU scheduling is defined as the process that specifies the order in which the work is to be done. So scheduling is done in the areas where more number of processes are to be performed. Okay. Obviously, when there are multiple processes, then we need the CPU scheduling. So now, first we will see FCFS scheduling. Just listen it carefully how this algorithm works, because this algorithm we have to implement today. FCFS scheduling, actually it is very easy. Once you listen, you can easily implement this. So FCFS, first come first serve scheduling algorithm. Sorry, first in first out, also known as first come first serve scheduling algorithm. This FCFS or FIFO simply queues the processes in the order that they arrive in the ready queue. The process, or it will execute the processes in the order in which they arrive into the ready queue. So in this FCFS scheduling algorithm, the process that comes first will be executed first. The process that comes first will be executed first, and next process starts only after the previous gets fully executed. Okay, you understood? The process that comes first will be executed first, and next process starts its execution only after the execution of previous. Okay. Now, uh, now we'll see this example of FCFS scheduling algorithm. Here you can see three processes are there: P1, P2, P3. Okay, and duration is given. Means this duration in some of the examples here you can see burst time, BURS, burst time is given. Means total execution time of that process. So we are considering there are total three processes are working in the system: P1, P2, P3. P1 requires 24 milliseconds to execute, P2 requires 3 milliseconds to execute, P3 requires 4 milliseconds to execute. Okay. As this is the first come first serve, so here order of arrival is also given 1 to 3. First process P1 is entered into the system, then P2 and then P3. And the arrival time is 0. Okay. So this information is given. Now, so here as we know, the first come first serve schedule available means whichever process enters first in the system that will be executed first. Okay. So what we have to do? So here in scheduling algorithms, you need to compute this burst time, turnaround time, waiting time. So first we see what is the definition of this arrival time. What is the arrival time? Okay, from the name itself, arrival time means the time at which the process arrives in the ready. Okay, completion time. the time at which process completes execution. That is the completion time. Now burst time. So already I told you burst time is total execution time required by the process. So time required by a process for CPU execution, that is known as burst time. Okay, so these things may be given. Okay, now you need to calculate these two in the programs. Okay, turnaround time and waiting time. So turnaround time is time difference between completion time and arrival time. You can calculate this turnaround time like this: completion time minus arrival time. Or you can see another definition for this turnaround time is the total amount of time spent by the process from coming in the ready state for the first time to its completion. This total time required by the process from its completion, from its means total time spent by the process from coming in the ready state for the first time to its completion. Okay, this is the turnaround time. So you can calculate like this: completion time minus arrival time, or turnaround time can be waiting time plus execution time. Okay, and how to calculate waiting time? So waiting time is nothing but time difference between turnaround time and burst time. Okay, so first we will see the example, then you will get a clear idea. Same example we have considered here. Three processes are there: P1, P2, P3. P1 requires 24 milliseconds, P2 requires 3 milliseconds, P3 requires 4 milliseconds. So first process P1 into system. So process P1 is selected for execution. Okay. So first process P1 is selected for execution. So waiting time for process P1 is 0, right? Because before that no process was there, no one was there. So waiting time for process P1 is 0. And how much burst time it requires? 24 milliseconds. So total 24 milliseconds. Okay. Now there are two processes remaining, P2 and P3. After P1, P2 arrives, right? So P2 is selected for execution and it requires 3 milliseconds to execute, right? 24 plus 3 is 27, right? First process P1 arrive, P2 and P3. So waiting time for P1 is 0. Then process P2 arrive into the system. Waiting burst time means execution time for process P2 is 3. 24 plus 3, 27. Okay. Now process P3 arrives into the system. P3. It requires 4 milliseconds to execute. But how much time it has to wait? 27 milliseconds. So total execution time for all the processes is 27 plus 4, 31. Okay. So this is the Gantt chart for this Fcfs scheduling algorithm. Gantt chart is a pictorial representation of the processes. Okay. So waiting time for P1 is 0. Waiting time for P2 24 milliseconds because it has to wait for 24 milliseconds. Waiting time for P3 is 27 milliseconds. Okay. And total execution time for all the processes is 31 milliseconds total. Okay. Burst time for P1 is 24. Burst time for P2 is 3 milliseconds. Burst time for P3 is 4 milliseconds. Okay. So here we need to calculate the waiting time of each and every process. Waiting time of P1. What is the waiting time of P1? Waiting time of P1. It does not have to wait, so 0 millisecond. Waiting time for P2. Whatever the figures are given, that figures are for just burst time. Okay. Waiting time for P2 is 24 milliseconds. Waiting time for P3 is 27 milliseconds. Now we need to calculate the average waiting time. Average waiting time is just waiting time of P1, P2, P3 plus divided by 3. Okay. This you have to calculate, and turnaround time also we have to calculate. But first you do this program. First you enter 3 processes into the system. So for that you will require the waiting time, burst time. Okay. So like that you have to complete it. Can you do this program? Yes. Still I have not taught turnaround time. Just you enter 3 processes into the system, enter their burst time, and just calculate the waiting time. Waiting time of each process. Can you do this? Yes.